we're going to talk today about the angles, not the angles, the area of a triangle. What is the formula for the area of a triangle? A squared plus b squared is the Pythagorean theorem. Base times height divided by 2, or 1/2 base times height. Have you ever wondered why that's the case? So if I take the height of this triangle, which is 5, and the base of this triangle, which is 10, multiply those together, I get 50. 50 divided by 2 is 25. Oh, 25.01. You guys are wrong. So the reason that's the case, there's a rectangle, and this triangle is exactly half of the rectangle. So the area of the rectangle is 50, and then you cut it in half. Well, anyway, it's just messed up. So what about now? Is it still 1/2 base times height? Here's the height. So the height divides the blue rectangle into 2 rectangles. There's one over here, there's one over here, and this portion of the triangle is half of this bigger rectangle, and this portion of the triangle is half of this rectangle. So this triangle and this triangle are equal, this triangle and this triangle are equal, and notice the height didn't change, so the area didn't change. What if I step outside? Oop, now the base is different, but is it still 1/2 base times height? Yes. So you can cut this triangle up and stick it in here, and it ends up being half. And notice it doesn't matter where. Whoa. Doesn't matter where I move that. The area of the triangle, calculated right here, is the same. These two are the same. Now, if I change the height, it will change. But if I change the base, it will change. But every single triangle built on this base between these two parallel lines will have the same area. Even if I move it way out and I create a super skinny triangle way out here, area is the same. Yeah, so this yellow, what you can see of the yellow triangle is exactly half as big as that. I'm going back to the beginning so I can save it. Okay. All right, so what if I don't have the base and the height? How do I calculate the area? That is our job today. So I'm going to draw a random triangle. Let's say I know that the base is 10 feet, but I don't know the height. But I know that this side on the left is, say, 8 feet. Is that enough information to calculate the area of the triangle? Well, let's think about it. If it's a right triangle, and I know where the right angle is, I could do a squared, b squared, c squared, but is this a right triangle? No. We're going to get to... So that won't work. Why does this not work? All right, so this is unknown. That's a problem. Can I calculate that? I could if I knew where on the base it hit. I don't know. So I have this small section here. If I knew that, then I would have an angle and 2 sides, and that's enough to figure out everything you need to know in a right triangle. In any random triangle, how much information do you need in order to determine that it is a unique triangle? There are 4 side angles. Side is one of them. Angle, side, angle, 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 side, side doesn't work. That's Casey's favorite. Angle, angle, side, or side, side, side. Okay? There are 4 of them. Side, 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 angle, side, angle, side, angle, side, and angle, angle, side. This is Casey's favorite. We'll just leave that up for all posterity to watch this video. That is Kate. We'll refer to that as Casey's theorem. Okay, so in this case, I know 2 sides, so these 2 are out. I either need to know the 3rd side or which angle? The angle between the 2 sides. This angle right here. Now generally, when we label triangles, we call the angles A, B, and C, and those are capital letters, and the side opposite that angle is the same letter, only lowercase. This would be little c, little a, little c, and little b. Okay? Side angle side always uses 2 sides, like A and B, and then the angle that's not already listed. So right now I know I'm looking at angle A, which is between side C and side B. Angle C is between A and B. Okay, so if I have a side length 8 and a side length 10, that could create an infinite number of triangles. I could open it up to almost 180 degrees, and I could close it down to almost 0. And every one of those would be a unique triangle. As soon as you pick the angle, though, you're locked into a unique triangle. So let's say that that angle is 25 degrees. Now the triangle is unique. So if you're looking at side angle side, that guarantees a unique triangle, and it's pretty easy to figure out the area. The formula for area is 1/2 base times height. Do I know any of that already? I know the base. So the area equals 1/2 times 10 times the height. Well, what is the height? So this here is h. How do I figure out h? How do we calculate h? I need trig. So let's look at SOHCAHTOA. And the only angle I have is this one. So I have to use that angle. Can I use 10? No, it's not part. Here's the right triangle. 10 is not part of that right triangle. So I have to use that one. Which trig function is going to use the height and 8? Sine. So the sine of 25 is equal to the height divided by 8. Solve for the height. 8 sine of 25, and I can stick that right here. 8 sine of 25. So the area of this triangle is 1/2 the base, which is 10, times 8 sine of 25. So to calculate that, 1/2 times 10 times 8 times the sine of 25. What if I would have chosen, wait, I did 1/8. Yeah, that's not going to work. Do you guys want to know how to get back and forth really easy? If I want to go all the way to the right, I can push second right, and it will jump clear to the end. Second left will jump you all the way to the left. Let's say I missed. So let's say I'm missing the 8. How do you insert a number without typing over what you already have? Right above the delete button is INS, second insert, and you can type as many things as you want. to stick it in that space. The delete right here. Insert. 16.9. That is the area of the triangle. What if I would have chosen 8 as my base? Would that change the calculation? So let me switch colors. I chose that as my base. This would be my height. Here's my right angle. And it's going to be h divided by 10. So it would be 10, 10 sine of 25. So it would be 1/2 8 times 10 sine of 25. And what do you notice? It's the same thing. So whenever you have side angle side, it's 1/2 times both sides times the sine of the angle. So in general, I have A, B, and C, which would be A, B, and C. The area is equal to, there are 3 different versions depending on which side angle side you're given. What would be one generic equation for this triangle? 1/2. Let's say we were given angle C. What would the formula equal? AB times the sine of C. What if I were given angle A? What would the formula equal? CB times the sine of A. Or if I knew angle B, the formula would be 1/2 CA or AC sine of angle B. So as long as you're looking at side angle side, you can't really mess this up. Because the A's and B's can switch as long as you're looking at angle C. Not a big deal. So there are 2 worksheets today. Here is the first problem on one of them. The area of this triangle is simply going to be area equals 1/2 times 32 times 19 times the sine of 47. Easy enough, right? Okay, but then on one of the worksheets you have to find the area of a regular polygon. What does it mean to be a regular polygon? Regular means all the sides are equal and all the angles are equal. So a regular polygon, here they are up here. Nope, here they are. An equilateral triangle, a square, a regular pentagon, regular hexagon, and so on. So let's say I had a regular, oh, what's a fun one? Pentagon, decagon. It has 10 sides. Okay, and let's say that the perimeter, I'm just going to make this up, perimeter equals 300, and I don't trust you, 300 and, what's a nice number, 64 inches. What is the area of that decagon? Now this is kind of involved, and there are several different ways you could reason through this, but they're all sort of going to involve triangles. So I know going all the way around is 364. So how big is each individual side? In this case, it would be 36.4 inches. There are 10 of them, 10 sides, so I divided by 10. Okay, and then I have this triangle here. How do I find the area of that triangle? So I'm going to zoom in a little bit. This is 36.4. Well, I need a right angle. So let's focus on this triangle here. What's the base of that triangle? So half of 36.4 would be 18.2. Everybody follow me so far? What else do I know about this triangle? One of the angles is 90. Good. Do I know any of the other angles? They do have to add up to be 180. But I need one of them to figure out what the other two are. There are two ways to do this. So what is the triangle angle sum for a decagon? Well, a decagon has 1, 2, 3, 4, 5, 6, 7 triangles inside of it. 8. Oh, when I drew 7, it made 8. So there are 1, 2, 3, 4, 5, 6, 7, 8. Right? Each triangle adds up to 180. So 8 times 180. Somebody do that. $1,440. Okay? And that means all of the angles add up to 1440. But how many equal angles are there? It's a decagon, so it's 10. So if I get rid of all of this stuff, each one of these angles is 144 degrees. And this angle here just happens to be, so if I draw this triangle here, this angle is, it's exactly half of this angle, which is 144. So this is 72 degrees. Now I have everything I need in order to figure out the height. So you could use trig. Here's theta. You could use trig to find this side, or you could use it to find this side. Doesn't really matter. It depends on, do you want to use 1/2 base times height, or do you want to use 1/2 AB sine of C? Because they'll both work. If you calculate for this, then just do 1/2 base times height. If you use this, then you're going to end up doing side angle side to calculate that. Doesn't matter. I think this is actually easier, although the worksheet doesn't want you to find that. The worksheet wants to be tricky. So to find this, the tangent of 72 equals 18.2. X over 18.2. So 18.2 tangent of 72 will tell us the height. What is that? Somebody calculate it out. Want me to do it? You don't seem sure about yourself. 56.01. The area here is 56.01. How many of those are there in this decagon? 20. There are 2 for every side. Here's the side, there are 1, 2. So I times this by 20, times that by 20, and I get the total area. Oh my goodness, I'm sorry. You're right. Sorry, that's the height. 56.01. Now I have to multiply these together and times them by 2 and then times them by 20. Thank you. So 18.02 times 50.01. Divide that by 2. That's the area of the little piece of the single triangle. But for every side, there are 2 triangles and there are 10 sides. So there are a total of 20 triangles equal to 450. So times this by 20, that's the area. Thanks, John. Somebody's paying attention. So let's do one more. Get rid of our decagon. Casey, what's your favorite number? 12. Boy, you want to make it tough, don't you? No, can't say 3. So let's say the perimeter is equal to, no, that's too easy. 72 centimeters. Oh, I meant to grab 12. I tried, I just missed. There we go. Decagon. Or this is a dodecagon. So the prefix for 12 is dodeca. This is a dodecagon. Okay, so each side length, we divide this by 12, and we get 6 centimeters. So I told you one way to calculate the total angles. We draw the triangles. How many total angles can you create in a dodecagon? 12. So if I were to do, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 and 10. Oops. This one, whoa! I think if I don't know how to do this. Okay, we get rid of that one. Go away. Now, the other way to do it, the faster way to do it, is this. Every polygon, regular or not, every convex polygon, meaning it never caves in on itself, has an exterior angle sum of 360. Now that, I don't understand why that's the case, it's just true. So an exterior angle is like this. So if I add up all of those exterior angles, I get 360. So 360 divided by 12 would be 30. Each one of those is 30. If that's 30, then how big is this one? 150. And that's actually usually a lot easier. So take 360, divide it by however many sides there are. That gives you the exterior angle. Subtract that from 180, and you get the interior angle. So now this angle here is 150. So that angle would be 75. So now I have a 75 there. And if I cut the side in half, I get 3. Now I can use trig to find the height. Am I going to use... No. Hey, that wasn't my mistake. That's the first. Am I going to use sine, cosine, or tangent to find x? This is theta. Opposite, adjacent's got to be tangent. Tangent of 75 is equal to x over 3. So I multiply by 3. 3 tangent 75. 3 times the tangent of 75 is 11.196. That is the height. So the area of this sliver is 1/2 base, which is 3, times the height, which is 11.19. And how many of those slivers are there in the entire figure? 24. Did I do that right, John? Okay, good. Multiply by 24. That is the area of the entire figure. Now, there's probably a formula out there that's a lot easier to just plug it in, but then you have to memorize a formula. It's just easier to... I don't even know what it is. But there probably is a formula where you could take the perimeter and plug it in, and anyway, but it's not worth your time to memorize it. Just figure it out. You'll be better off. Yes. All right. Good luck. Who needs